Welcome to the Zoomtown experiment. The experiment where it seems like anything and everything that could possibly go wrong will go wrong. This has been a long journey now. We're, I think, into almost a year and a half of this whole experiment. And there's a continual fight or a battle between me and the robot and the software to get accurate positioning for the robots to move. Now, if you're not following along from previous videos, I suggest that if you want a better understanding of today's video, you might need to watch the one from our last video, the previous one. I'll try to remember to put a link down in the description below. But let's start with how I'm going to present this, because the problem is very complex. It's very heavily involved in computations and the code and observations that were incorrect. And it made a whole mess of everything that probably has been lurking in the background since the beginning of this project. So with that, I'm going to put up an outline, and then we'll kind of follow along with a presentation up in the corner so that you can understand what I'm going through on this one and where we're at. The problems encountered would be the first thing we're going to talk about to refresh everybody's mind. Then I'll walk you through the discovery process of how I looked for the cause of the problem. I'll show you the findings and then the ultimate solution of what I've come up with. And then we'll talk about the accuracy and repeatability results, which, by the way, just so you're not hanging on suspense, they actually are working very well now. And then reflecting on the mistakes I've made. A lot of times that's never considered in problem solving, where you get so excited to go from problem to solution and you wash your hands and run away. I try to force myself to look at the stupid mistakes I made so that hopefully I won't repeat them again in the future. The problems that I encountered were positional problems with inconsistency. All along in the project, I could never get the system configured such that I tell it to go 10 inches and the Zoomy would actually go 10 inches. There would always be some strange variability there. Or I could get it tuned to go 10 inches, it would hit that spot, but if I told it to go to 30 inches, there'd be variability there. But more recently, in the last few episodes, a new problem, I shouldn't say a new problem, the underlying problem really came to surface, and it was obvious something was going on. I was running some tests. I added in a print statement to print out data while the program is running. And that's often a lot of data. I like to take that, throw it in a spreadsheet, analyze it, and then go from there. Well, I added in a print statement to the program, and the Zoomy, instead of going 30 inches, it went 20 inches. I took that print statement out, and then it went 30 inches. I think, this is crazy. Well, to further dig into that on the problem, how it's presenting itself, I substituted print with a sleep statement, figuring print takes a lot of time in MicroPython. So let me just throw in a sleep statement, and that way I can control the duration very accurately, how long that dwell or pause is. Sure enough, that changed how far the Zoomy moved again. Instead of 30 inches, it would go 20 inches. At that point, I'm really puzzled. My mind is reflecting back on how calculated distances never really matched real-world conditions. And theoretically, it should have been pretty darn accurate. Now, my observation at this point is this. If I add a print or a sleep in the running program, so it slows it down, The Zoomy, if that's causing a problem with interrupts, the Zoomy should go further. But in this case, it was stopping short. And it was roughly about 30%. And that's a very loose and rough number for the purposes of this discussion. So that's what we encountered, and that's how it presented itself to me. So next up, we got to go through and try and discover where this crazy problem is. In order to do that, I would have to test to see if the encoder counts were correct. If they're not correct, and somehow I'm getting more than I should, there would be another indicator somewhere to tell me that that's happening. In order to do that, I thought, well, if I measure the time between encoder counts, I would be able to see counting faster or slower, or getting too many counts or not enough. And I figured time would be the best way to do that, the time between encoder counts. I found a variability in that timing as I'm going through this process. So what I did to discover that, I put a time calculation from one interrupt to the next, and then I print that out between each interrupt call. And that gave me a very accurate microsecond level accuracy of how far between each of those interrupts occurred. There was a lot of variability in it, and it would peak out all the way up at 14 milliseconds, with a lot of them at 10 milliseconds, and then a few at 7 milliseconds, and then the rest of the data way down in there in about a half a millisecond or less. And that was really the underlying area where the real counting was occurring in normal processing. So I got all this variability, and I needed to get rid of that and look at more pure data. So I reduced the code to an absolute minimum to reduce all the variability that could be introduced by the main loop program running all these different tasks. So I just commented out a bunch of tasks out of the main loop so that they wouldn't run. With the ability to see the timing now consistent after eliminating all those extra moves, I could start to see that there wasn't a problem there. If it's all counting consistently, time between each count, the problem had to be somewhere else. Now, the variability could have caused a problem, but at this point, I've reduced it down to minimize that variability. That caused me to think that I call it the distance per count, how far the Zoomy moves for each encoder count. That'll be a big part of this discussion as we move along. In order to do that and understand that how far the Zoomy actually should move, I needed to verify the gear ratio between the motor and the axle. The motor's spinning really fast, but there's a lot of gearing between the motor and the output shaft. The encoder is counting on the motor, not on the output shaft, which drives the wheel. Early on in this whole project, I could never find accurate information, so I never was highly confident that I had that value right. And it is very critical to this process. So once I figured out a way I could test the gear ratio that was reasonably accurate, because I can't find specific data for it, I recalculated the distance between counts, and it was off by a substantial amount from what I got through practical implementation, meaning I would take a test, adjust it up or down until I finally got, if I told it to go 15 inches, it went 15 inches. That was actually a huge mistake, and we'll talk about that a little later. But through that, I discovered that my distance per count and the physical distance the Zoomy was moving both were off about 30%. And that was the unifying factor that led me to the solution. So now at this point, I've got a couple of mistakes that I've made, and they're contributing to a problem. Now let's move into the findings of that discovery process. I was experiencing or seeing inconsistent time between interrupts caused by no time in the main loop to handle interrupts. Most of the time, if I wasn't printing or sleeping, the main loop is just running as fast as it can possibly go. That's a problem, apparently. And there were long duration routines that were creating a problem and blocking interrupts from running. And that one in particular was the tiny code reader from Useful Sensors. That was used to read QR codes that I was placing along the route for the robot to travel and do an update for its current position. That was a huge surprise there. I never realized that was introducing a problem. The other thing that I found was that the gear ratio was incorrect between the motor and axle. My data early on, I was using a ratio of 100 to 1. Turns out it's 150 to 1. Interesting that that's about a 30% error. And the earlier assumption of it being 100 to 1 was on very vague information from, I don't believe I had a data sheet, but I did have the specifications from one of the sellers of these motors. And turns out that was wrong. Big mistake on my part. And then finally, the other thing that came about out of this, I had an incorrect distance per count calculation. And that was through, it was originally calculated correctly, but I had to adjust it to get the results that I needed. The ultimate solution to this whole problem was that I needed to add in intentional sleep in the main loop. If the main loop runs wide open, it will never be able to go out and get interrupts always. It'll miss some. And that led to a lot of the problems that I experienced. I did read up on this earlier on when I first started playing with MicroPython, and I don't recall that being a problem. But again, you know how it is. You read what you want, you read something and interpret it the way you want it to be read. And I think I made a very bad decision at that point. The other thing was I needed to change the distance per count to the proper calculated value. And if the Zoomy did not respond properly to that, then something else was incorrect. And then finally, I disabled the tiny code reader, the QR code reader, for all purposes right now. I don't think the new process that I've been working on needs it for anything other than one specific application or portion of the whole process. So I can turn it off right now and it will not affect the Zoomy driving along the streets, pulling in and out of driveways, etc. It will have a very specific purpose that should be only needed, that won't cause problems with our driving or our cruising along the roads. I got to work on that a little bit more. The end result of all this was very, very promising. To do my first tests, I set up a test track over in Zoomtown behind me there, where I had a straight run of road and I had stopping points at 20 inches, 40 inches, 60 inches, and 75 inches, which is about the longest distance across any road section in Zoomtown. And on the metric world, that would be from up to almost 2 meters in length, a little less than 2 meters. So those would be the test runs I would do to monitor the stopping points. I also, during testing, would add print statements, take them out of the main loop, add sleep statements, take them back out. I would have the Zoomy running at different velocities. Different velocities could certainly affect interrupts. If I'm going faster, I'm getting more counts per second, and if the interrupt can't keep up, it would show up in that test. Then to make things really interesting for the test, I disabled the sensor that would see the marker tapes, which are positioned at the end of every move. We ran that without those markers, just working purely off of the encoders. I had a deviation or amount of error across each one of the different lengths of a maximum of 0.1 inches. If you're into the fractional world, that's less than 1/8 of an inch. And if you're in the metric worlds, that's about 2.54 millimeters. That is the best I've ever got just working straight off of encoders. I was thrilled with that result. And the nice part is everything correlated throughout the whole process. The distance per count, the number of counts were very accurate to what I was getting physically in movement and via the program and what I told it to move and getting that exact result and counts. So the encoder counts were matching the distance traveled based on the gear ratio and all of that. Everybody was in agreement. So with that test out of the way, I went on to another test. I then implemented having it stop at the marker tapes at each of those intervals, ran the same test again, a couple more hours time, and the deviation or error at end of move was down to about 0.05 inches or 1.27 millimeters. Again, I'm influencing all of that behavior by adding print statements, taking them away, sleeps, different velocities. A lot of variables were thrown into that test to see if it would have a cause and effect. Good news is I am thrilled with the results. For those of you that have been following along since the beginning, you know my goal's always been to be within 1/2 millimeter. I just am now coming to the realization, if you will, that my goals and desires are probably not possible with the hardware that I'm working with. It's just beyond the capability of it. Throughout this whole process, and I'm not talking about the last few weeks where we ran into this problem, I'm going all the way back to the beginning. A lot of times as a programmer or working through a project like this, your tendency is to minimize variations in feedback as you're developing the process. Perhaps it's wishful thinking, you're hoping it'll just go away, right? Well, that can compound problems such as this one. Going back all the way to the beginning, and of course now, one of the big mistakes that I made was not working with accurate data, the gear ratio. That was key to having that piece of information to bring the whole puzzle together and make it work correctly. Without it, I was really kind of guessing. In the world of engineering, you don't guess, and I know better. But here we go. Lesson learned yet again, right? Using, I have that feature of distance per count, and I can adjust that up or down, and that would affect how far the Zoomy would go based on the number of counts. If I manipulated that number, I could get the result I wanted. The problem was I'm masking the real problem, and that had to do with the encoders were not, or I should say the interrupts were not counting every encoder trigger. So I covered up a problem all along, and it came back to haunt me. Again, that was another one of those I knew better, and I shouldn't have done that. The next one that was a mistake is not knowing interrupts were not triggering. that goes back to a comment I made earlier where I'm thinking about what I read about interrupts and how they behave in MicroPython and on the Raspberry Pi Pico microcontroller. And it clearly states in there that you have to allow time for the interrupts to behave. Tight loops can create problems. And I think wishful thinking, I just pushed it out of my mind. But again, another very poor engineering mistake. And this last one is really one that just messed everything up. And it's a problem that I created from my own self. And it was just purely wrong and poor engineering on my part. It's misinterpreting the behavior of the problem. Go back to the original problem. We need to move 30 inches. I tell the Zoomy to go 30 inches, but it stops at 20. And that's when I added a print statement. Prior to that, I told it to go 30 inches, and it went 30 inches. With that thinking, the only thing I can reason out is that by adding that print statement, I'm somehow getting too many counts. It's like it's influencing the interrupt handler to re-enter itself, which is a possibility, or to double trigger, etc. Because if I get too many counts, the Zoomy, as it's moving along, will think, oh gee, I already traveled 30 inches based on the count, but I'm going to stop at 20. Big problem, right? Well, I really set myself up for failure on that observation. Earlier on in this whole process, I calibrated the distance that I wanted using the distance per count. And when I was doing that, most likely I was running without a print statement or with a print statement or a sleep command, something like that. And I got the wrong number of counts, and I would stop short or go too far. To fudge that, I would add more or less value to that distance per count. What I was actually doing was concealing the fact that I was having trouble with the interrupts because it's not clearly obvious. And with that, I modified another variable, the distance per count, to cover it up. And that was the beginning of the end for everything. Turns out, had I really just observed a little bit better and thought a little bit longer, I could have easily reasoned all of this out by just taking a step back, not jumping to the first conclusion and analyzing the data, which ultimately I ended up having to do, which took several days, and that was the proper thing to do. Just dive into it, dig down deeper and deeper and deeper, find what you can, apply the changes, and then validate the results honestly. Don't just get close and then fudge numbers after that. So those were 4 major mistakes, all of course my fault for not taking and doing due diligence to do things properly. But nonetheless, at this point, it was a great experience. I always, so to speak, I always love challenges like this, digging into the problem and digging and digging and digging, especially when I have time. And the outcome at this point looks very, very promising. So where do we go from here? Well, with this new understanding of the problem and a resolution to it, now I have to revisit all the stuff that I just did in the last few weeks and retest all the maneuvers I've been working on. Sweeping turn, pivot turn, cruising, parking, unparking, that sort of stuff. Because all of that is going to be influenced by this most recent change. Once I get past that and then get the rest of the maneuvers covered, such as pull up and check address and return from check address and a few other little things. Once I get those all back online, then I need to go on to expanding the test runs. The longest one so far has been on a northern road, on the vertical road that from your perspective on the right end of Zoomtown, where I would go along, pull into each driveway, back out of it, and continue on to the next one. Well, now I'm going to go all the way around the block on the next test, and if that's good, then I can move on to reversing directions and adding a lot of the other issues that would come up with those same maneuvers, but from a different perspective, meaning right turns versus left turns, etc. So that could be anywhere from a week to 2 weeks to 3 weeks out, and that's when I should hope to see you the next time with more good news. Thanks so much for following along on this crazy journey, and I look forward to seeing you next time.